Welcome everybody. My name is Łukasz Mendyk. I'm product manager for Comarch catalog-driven service fulfillment, and also I'm responsible for innovation in the space of NFV SDN across Comarch OSS portfolio. Today I have probably tough task because when I tended to make presentation in previous events, I tended to allocate my speeches to technical tracks. Today I'm participating in the business track. So, but I still hope that my presentation would be appealing both to business-oriented people and also will provide some technical insight. So I will start with deciphering my title of my presentation. As you can see, the customer service word should indicate that it's targeted toward business-oriented people, which means that even if NFV SDN is exciting technology, at the end we should prove that that technology would provide better customer services. But in fact, the word which I want to attract your attention is experiment. My presentation would be about how NFV SDN can change the way operators should innovate and adopt some concept from Silicon Valley. What I mean by that, I'm referring to phrases like fail fast, beta services. In other words, whether NFV SDN would enable operators to experiment with new customer services without being afraid that new prototyping services would affect mature services which have been rolled out. So more or less that's what my presentation should be about. Let me just also indicate some points which I'm going to touch. So to explain how to achieve that goal, probably we need to demystify the word orchestration. You probably have noticed that everybody is using the orchestration as a magic word which should explain everything. I would try to roughly explain what orchestration is. I would pay a lot of attention on model-driven orchestration as a key element. And the reason why I'm going to do that is because the whole concept assumes that experimenting should be based on a model where you model new service, new version of a service, new version of VNFs you can onboard, and then start to experiment with services which will be targeted to probably early adopters. And of course, I would also say that VNFs could be treated as building blocks or Lego boxes from which you should be able to create new services. First thing which I would like to focus on is what is the final goal of NFV SDN? Probably this slide is not very mind-blowing because we have heard from operators that they admit that NFV SDN is not about cost reduction, but more about new revenue sources, new services. So from that perspective, probably I'm not saying something new, but what I would like to pay your attention is to the wording where you have reducing time to market, which I would consider a conservative way of describing the goal, via boosting innovation, experimenting, which I have used, to fail fast, beta services, which is to incline that I think that NFV SDN should enable operators to compete and cooperate with over-the-top players like Google, Facebook, or all these smart guys from Silicon Valley. So I think that NFV SDN adoption goal finally should be to change the way the operators are innovating. And of course, it's not only about reducing time to market, but changing it in so radical way that new services could be delivered as by experimenting with early adopters. Okay, now I will move to slightly more technical details. I promise that I will explain what the orchestration is. I'm a little bit smiling because my colleagues were saying that if I present such a diagram, UML diagram, I will scare off all the business-oriented people as it's too difficult. But I take that risk because I think that that model is not that complicated. In fact, it's simple. And I think it can be explained to business people in the way that at the top, you have the acronym CFS, which stands for Customer-Facing Services. I'm referring to TMF SID model, which defines customer-facing service as a service which captures the value a customer is to get. So this is something which I think business-oriented people are so all about. Beneath, you have resource-facing services, which in other words are technical services, and they capture more technical aspect of the service, and these lines between these boxes are to indicate that you need to be able to identify what you need from technical perspective to provide value to the customer. Beneath RFSs, you have network functions. Before that, let me also say that RFSs or network services are to abstract from the fact whether these network services are built on top of virtualized versus, let's call it legacy network. Beneath network services, you need to decompose to identify network functions which you need to implement the technical services. And here, probably you need to differentiate whether you are using virtual network function or physical network function. But even here, what we are promoting to be able to manage the hybrid network, we think that it's a good idea to have abstraction layer which defines network function in the way that you can treat them as a black box, meaning that you don't care whether it's virtualized or non-virtualized network function. In other words, if you have a router probably should behave the same way as, no matter if it's virtualized or physical one, at least in the aspect of what functions it is providing. Otherwise, why you would call virtualized router if it's not to be a router, simply as that. But below there are differentiation that for traditional legacy network functions, their implementation assumes being hosted by dedicated hardware. And what is important, the lifecycle of network function as an abstraction concept is tightly coupled with the dedicated hardware. So in other words, when you install the hardware, you have hard-coded what network functions are being provided on that. And this is something which is completely different when we are talking about virtualized network functions, where virtual network functions are decoupled from dedicated hardware. In fact, a little bit simplifying, virtual functions are hosted by virtual machines, which are finally hosted on physical devices, when in this case are blades, commodity hardware. And what is important, the life cycle of these physical devices, which are blades, are completely decoupled from network functions, meaning that you probably install blades and you can dynamically create or deallocate new network functions. So this is the main difference between virtual and network functions. Why I'm talking about that? Because I promised to demystify the word orchestration. I think that we can distinguish at least 3 layers of orchestration. The top layer orchestration, I would call it a service orchestration. Why I'm distinguishing that? Because I think this is something which already exists in most of the modern OSS system. Probably we don't use the term orchestration, but simply catalog-driven fulfillment, where customer order needs to be decomposed to technical orders, which needs to be implemented. So in other words, that layer of orchestration does not need to know whether the network services to which it delegates the request to create network services are being implemented on virtualized or non-virtualized network. The second layer is what I think is manual orchestration, where the manual orchestration comes into play, where you try to identify how the network functions are being implemented, whether they're implemented on virtual network functions or physical network functions. And going one step further, you need to understand that if the network service is being implemented on virtualized network, you probably need to instantiate that virtual network function. So you need to know how much RAM, how much CPU, storage, all the network NFV infrastructure resources need to be allocated to host that element. Okay, so the key message here, the orchestration, end-to-end orchestration is model-driven, where you, coming from the top, you get the customer order, so you concentrate all the value to the customer. And finally, via these abstraction layers, you need to know what you need to instantiate, whether you instantiate physical network functions, it's also sometimes might be needed, or how to configure that. And in the space of virtualized network, that you need to instantiate virtual network functions. The reason why I'm talking about that, because if you want to experiment the fact that it's to be a model-driven and automated thanks to that, should enable you to easily experiment with new functions by just changing the models rather than hard coding how the network function or customer service should be delivered. And that's the key point here. So now I will move to something which needs to happen before you get customers being delivered customer services. So before you start delivering service, you need to define that. We might say that network function virtualization technology enables you to onboard VNFs as a starting building blocks from which you are going to create network services and finally customer services. By the way, just a remark that I think the key is a model. Whether this model is expressed in Young, Tosca, is not that important. I'm not saying that Young is not important at all, but what I'm saying is that Young is just a meta language. I mean, a language for describing the model, not the model itself. So I think the key is a model. By the way, UML, it's also Unified Modeling Language, is also the model from which you can generate Tosca or Young model, or do the opposite. You can import the descriptors of VNFs into the service catalog, for example, which is to manage the complete end-to-end model of a service. But what I'm describing is in fact nothing new in the sense that even prior to NFV SDN, there was a concept of catalog-driven fulfillment where you could, let's say, onboard physical network function and then define network services and finally customer-facing services. So that concept just shows how nicely, I think, introduce NFV SDN technology to be able to manage hybrid network in more or less a unified way. So what differentiates NFV SDN from the aspect of experimenting and reducing lifecycle for new services? I think that for sure the fact that network functions are software-based helps because if it's pure software, upgrades are probably much cheaper. Probably also it means digitalization of network function. What does it mean? If you need new network function, you don't need to buy any equipment and ship that into your network because VNF is a digital asset which you can get and then have deployed across using your own network into many places into the network to have it instantiated. But is the fact that something is software-based, does it guarantee that it would be easy to manage and innovate quickly? I don't think so, because we all probably hear the term legacy network, legacy software, meaning thousands of codes, hard to maintain, difficult to update. So probably the fact that something is software does not guarantee you the success unless you have lifecycle management tools which enables you to manage the software in component using the term of components or microservice. I think is also now very popular buzzword coming from IT technology. But I think that what is crucial about network functions being a software, it means that you can have many different versions of the same function coexisting even on the same blade. This is something which I think has not been possible in physical world, where you could not experiment with new network function, or such experimenting would be very, very difficult, expensive, because you would need to install new hardware, or if you upgrade firmware of physical devices, you would risk that this network function will impact all your existing customers, impact the implementation of your services. VNFs being a software means that you can have instances of VNFs sitting together on even on the same blade, which are purely isolated between each other. This means that it should enable you to experiment with new network functions, to create new customer services without the fear that if you do it, you will impact your probably millions of customers. So that's where I'm getting to the concept where VNF should enable you to have VNFs and experiment with new customer services, which would be directed towards so-called early adopters, using, once again, I think terms popular in Silicon Valley. And then if your new customer service succeeds, you can expand the number of the people to which you will target that service. Before I get into details how to realize that vision, let me focus on one important thing. It's not only about the models, about systems, architecture. I would say the innovation is all about the people, I would say. Here I have indicated two roles on mindset event. I call them product manager versus service manager. Product manager, I'm referring to the mindset which is concentrated on commercial aspect. He knows what customers needs, how to sell services. He knows how to prepare the offerings, define the pricing, define who should be your target group. So that person is, would say, more business-oriented. Service manager is more about defining how to implement something. He probably knows everything about the network from bits and bytes perspective. And what is important to have innovation, you need to have these guys cooperating, probably in iterative way. By the way, it's not the new word, probably you have heard that many times. Once again, here you have a model which describes what these guys are doing. Product manager, I'm assuming that he concentrates on defining product specification offerings, which capture the commercial aspect of a service, while the service manager defines resources, services, technical service, and also customer-facing services. And by the way, customer-facing service is something which is a gluing element between the world of the technical guys and the product manager, meaning that from service manager, customer-facing service, it's as a final product of what these people should define. From product manager is a starting point to prepare offerings towards customers. In other words, they need to be able to collaborate. And maybe one explanation, that slide I'm using for many years. I used it before NFV SDN has been introduced, and I decided to reuse it, not because I'm lazy and I didn't have time to make this for this presentation, but I wanted to show you that from one hand, NFV SDN does not change anything, and at the same time, it's introduced dramatical change. What I mean by that you might ask why there is this reverse pyramid. This reverse pyramid was to suggest that innovation rate at resources is rather slow, because in traditional network, innovation in resources required very costly upgrades of the network. So network operators quite often consider network at the physical, as the technical layer as a commodity. They even have some infrastructure sharing initiatives, meaning that two competing operators were sharing the same network, but still they were competing on how I sell the services to the market. So that was the era of a competition. So still, probably the model makes sense in the sense that when you need to introduce new VNF, you are introducing new resource. And finally, you need to be able to identify what new services you are going to implement. I think what might change in the future, I hope that SDN especially is all about, that part would be extended, meaning that if you can program the network, maybe instead of innovating only at product layer and offering layer, you would be able to create a network dedicated to your application. So in other words, the NFV SDN should reduce the cost of innovation of resources and help these two guys to cooperate. So for example, if product manager has an excellent idea of new service, instead of hearing, okay, but IP layer behaves as it has been defined, maybe he is able to, by SDN technology, redesign how even the packets are being forwarded, so that the dummy pipes can become the smart pipes in favor for some products and applications. Okay, I promise to provide some more details. So the whole concept assumes that if VNFs are software-based, you can relatively easily experiment without risking the danger that you will impact your existing customer bases. Once again, I will show the model, meaning that this model is managed in service and resource catalog. What I mean by that when you are introducing new version of VNFs, you need to be able to track what would be the impact of the new version of a service on our network functions, and finally on on the customer services. Why is it important? Because when experimenting, if you think that your new version would impact your existing customers, existing services, maybe it's worth to introduce new version of function, a new version of a service, and even new products, and in a way get to the point that you have a kind of a slice of a network dedicated for experimenting with new services. Just to wrap up the business part of my presentation, I think that technology is here. I think that this concept requires not only new technology, NFV, SDN, and the lifecycle management based on model and catalog and service and product catalog integration, but also about the mind shift. And what I mean is that, once again, the wording. When I read literally fail fast, I'm not native speaker, English native speaker, so I try to identify what does it mean, fail fast. We know that business is not about failures. On the contrary, it should be about being successful. So probably fail fast doesn't mean that you should fail. Rather, the opposite, the path to the success is via failures, by trials, experiments, which you are not afraid because you control the scope of these failures. Another term is beta services. Traditional telco operator might say, what does it mean? That we are launching untested services to the market? I would say that it shouldn't be approached like that. Beta services probably means that you in a way, you launch the untested service, but you launch it to your early adopters, and you give them the message, not that I'm giving you untested service because I disrespect you. On the opposite, I want you should be able to get engagement of the customers, so they can be early adopters who can provide you a feedback, so you can improve your services. In other words, if beta services should not be treated as an easy way of providing untested services, rather the opposite. Operators should probably have also the team of people who collaborate with the early adopters, getting the feedback and tune the service, so these early adopters have the impression that they are partner to create new services. If that is, and I think this is how the over-the-top players are working. They adopt that idea to experiment and have these experiments be perceived not as something which can damage your brand, but rather the opposite, that your brand of your telco would appear as innovative brand which treats your customers as partners in introducing new services. Thank you.